Okay guys, this is lesson 9, and I do recommend watching this video because he explains a little more of how to find the RS configurations with Newman projections. I wrote these things here because this lesson is mostly focused on double bonds, and we're going to see what happens like when we have an odd number of double bonds, or like here when we have an even number of double bonds. So when we have an even number, we have to look for a chiral center. So we'll be looking for the R and S, and then the odd we'll be looking for E or Z. So before I go into the chiral centers, let's just start by naming it. So I've got 1, 2, 3, 4, 5. I'm going to put penta. So this is a pentadiene. If you take off the A, it doesn't really sound right, pentadiene. So that's why we put the A. We do our dash, and then it doesn't matter which way you go because either way, they're both going to be at the 2 position. So I'll be counting left to right. So I've got 1, 2, I've got 2 going to 3, and 3 going to 4. So that means I have 1 at 2 and 1 at 3. So I'll put 2, 3, dash DN. I don't have any methyls, but I want to check for the R and S conformation. So this is a little different than what we're used to checking with the conformations on like normal molecules. So what we're going to do is the carbon at the end of a double bond will be compared with each other, and to do that we just turn it around and we'll put this one behind this one, so it'll look like this. And then the thing about this is that, so basically we're going to evaluate this molecule first and then move on to this one. So this is going to be the highest priority, I guess you can say. We're going to figure out, obviously this is the highest here, and this is will be 2, and then we'll move on to this carbon, and the highest priority would be here, and then it would be hydrogen. So it's a little different than what we're used to, and I hope that made sense, but let's turn it around. So as I was saying, the highest priority here would be 1, the methyl, and then it would be the hydrogen. So keeping those in mind, then we move to the back carbon. So the greatest priority there would be the methyl, and then the Okay, so this is 1 priority, and then 2, and then we go back to the back carbon, and then we have our first priority, and then our second hydrogen. So 1, 2, 3, 4. So remember, we're doing from the first carbon first, these 2, and then we jump. We know that this hydrogen isn't higher priority than this, like in a normal molecule, but when we're doing the Newman projections, for that, this would be because it's on the first carbon. So we just turn around again. 1, 2, 3, 4. So it's going right there to the right. So we can go ahead and put R. R penta 2, 3 diene. So let's see if that is right. Okay. So it takes a little bit to get used to. Okay, so this is the naming one. We see we have an odd number of double bonds, and this is where we would do the E and Z conformation, but it's kind of easy to see that it's got hydrogens on the side and hydrogen on the side. They're all the same priority, so we don't have to worry about the E or Z in this molecule. We'll do 1, 2, 3, 4. We have buta, and then we'll put 1, 2, 3. Tri for 3, and in. We've already established there's no E or Z conformation, so we can leave it like that. So I think of this as just one big giant double bond, and then I focus on this side and then this side. Okay, here we have a drawing one, and we know it's going to be an odd number of double bonds because there is an E. So I'll start with what I'm most familiar with, which is the hexa. So 6 carbons, 1, 2, 3, 4, 5, 6. And then I'll start doing my double bonds. So I have 1 at 2, 3, and 4. So I've got 1, 2. So I'm making 1, 2 going to 3, and then 3, 3 going to 4, and then 4, 4 going to 5. add my hydrogens, hit arrange, and now we're just going to treat that like one big double bond and focus on the priority. So I have my first priority opposite to my first priority over here. So that is E. So this is good to go. So I think the odd number of double bonds is a lot easier because you don't have to deal with the Newman projections, you just have to deal with the E and Z, which isn't too bad. Okay, so I moved it around this way because I want to start this as 1 because that's where the double bond is. I don't want to start here because then I wouldn't have the smallest numbering scheme. So I'm going to start here 1, 2, 3, 4, 5. So I've got my penta. Triene. I'm gonna go over here, and you can always just write like the penta first and then the dash. Either way is good. I start at 1, and then 2 and 3. Make sure to have all your dashes, and then look for any methyls. So I see we have a methyl over here, or you can consider this one the methyl. Doesn't really matter. 1, 2, 3, 4. So 4 methyl, penta 1, 2, 3 triene, and then we can go ahead and turn this around to check for the chiral center. But what I see is that we have the same like duplicate, so I don't see how we would have a chiral center because we have 2 carbons here, they're the same priority, and the 2 hydrogens here, they're the same. That'll make a little more sense once I turn it around. Oh, you know what? I'm sorry. We're doing odd numbers, so we're not doing even. We have an odd number of double bonds. So actually we're doing easy conformations, so that's why it doesn't, these are the same priority, these are the same priority. So either way, we're good to go. Now if we had a methyl here and like a hydrogen here, then we would have an E or a Z. Okay. So let's start with the longest carbon chain. 1, 2, 3, 4, 5, 6. Right, 1, 2, 3, 4, 5, 6. Okay, so that's a hexa. We have 3 and odd numbers. So 3 triene. I'm gonna skip up to after the hexa and do my dash. 1, 2. So 2 going to 3, and then 3 going to 4, and then 4 going to 5. So we got 2, 3, 4 dash triene. And then I'm going to look for that EZ conformation because we do have an odd number of double bonds. And I see that our highest priority is up here on the top, and our lowest priority is here, and that's the same on the other side. Highest priority is up here, and our lowest priority. So Z for same, as in same. So I'll do Z dash hexa 2, 3, 4 triene. There's no methyls or anything, so we should be good to go. Okay, we've got 1, 2, 3. So I'll do propa, and then it would be diene because we only have 2. And this one we're going to do dash, and then we have one at the 1 and then 1, 2. So 1, 2 diene. And then we have an even number. This is kind of what I was talking about before when I had I was talking about the RS, but I had an odd number of double bonds, but I'll go ahead and show on this one too. We have the same priority, so we're not going to have an RS conformation. And we can see that when we turn this around and put that back carbon of the double bond in back of the front carbon of the double bond. And by the way, it doesn't matter which one you put in front or back, you're going to get the same conformation. So we do this, and we see that all these hydrogens the same priority. There's no way to put this as a 1 or this one 2. So that's how we know that there's no RS. So propa 1, 2 diene. Okay, buta, so I'm going to start with what I know. I know butadiene is 4 carbons with 2 double bonds in it. So I have a double bond, 1 going to 2, and 2 going to 3, right here and right here. I'll add my hydrogens, and the question doesn't specify whether there's an R or S, so we're good to go. And this one as well, we can see if we try to, just to show you guys, if we try to do an RS conformation, when we turn this around, there's no way you can do like 1, 2, and then those are the same priority in the back. So there's no way to figure out a conformation. If we had a methyl here, we'd be able to, but since we have 2 hydrogens here, we can just not worry about it. But if you guys always want to be sure, when it comes to the naming, so I know the drawing already specifies, but when it comes to the naming, you can always turn it around and see that we can't prioritize those bottom 2 hydrogens. So we can leave it like that. Let me see if it's right. 1, 2, 3, 4. It looks about right. And this homework isn't too bad. We just got to keep an eye. I know sometimes I miss methyls and it messes me up. This is also an even number of double bonds. So we can do the RS conformation, but I see that we have 2 methyls on the side and 2 hydrogens on the side. So there's not going to be a way to prioritize that. When we turn it around, these methyls are the same priority. So there's no way to label one as one. So we know there's no RS conformation. I'll start with my longest carbon chain. 1, 2, 3, 4. I know that's buta, and I'll do my dash. I've got a double bond at the 1 and at the 2. So 1, 2, and then it's 2 of them, so di, and then in, and then we'll go around front, make sure we get that methyl. So we have 1, 2, 3 methyl, butyl 1, 2 diene, and we've already established that there's no RS conformation. Okay, we've got an odd number of double bonds, so we might need to look for easy conformation, but at the same time I can see that we have 2 hydrogens here. So I'm going to turn around because I like to read left to right. Got 1, 2, 3, 4, 5. I've got my penta, and we have 3, so triene. I'll go to the after the A in penta and put my dash, and I have a double bond at the 1 position, at the 2 position, and at the 3 position going to the 4th. So 1, 2, 3 dash triene. And lastly, I want to add my methyl. So I have 1, 2, 3, 4. I don't have a methyl, it's a hydrogen. So we should be good to go. I know with the easy conformation, we have 2 hydrogens. These are the same priority, so we don't have to bother with that. Again, if this was a methyl or something, then that would be Z for zame. If this was a methyl, it would be E, because the highest priorities would be on the opposite sides. So we can just leave it like that. Okay, last question. We're going to draw S-penta-2,3-diene. So this one's going to be interesting because we actually have to deal with the conformation and change it if we need to. So I'm going to start by drawing with what's most familiar, which is my penta, which I know is 5 carbons. So I've got 1, 2, 3, 4, and 5. I don't have any methyls. I'm going to go ahead and start drawing my double bonds. So I have one at the 2 position. I've got 1, 2. So I'll draw 2 going to 3. And then I have one at the 3 position going to 4. I'll add my hydrogens and hit arrange. And then we're going to check that conformation. So let's go ahead and look at it. So it doesn't matter which carbon you put in the front. Like I said, it's going to be the same conformation either way. So I'll put this one in the front just to do it. So this is going to be the one that I take that I'm looking at the priority first, and then I'll move on to the one in the back. So there it is stacked up. Let me move this over. Okay. Okay, so I have my first priority here, this methyl. The hydrogen will be my second priority. And then now we're moving to the back carbon. So for the back carbon, I've got my first priority here and my second. So putting it all together, I have my first, second, third, and fourth. So 1, 2, 3, and 4. So it was going right there to the right. So this is R. So this is actually the wrong conformation. I haven't seen what happens if you can just mirror this, but let me try it just to see if that works, because that would be really helpful. So I'm going to put this in front, and now I'm going to do my conformations again. So I have these two in the front, just to keep it out, because I know sometimes it can get messy seeing which one you have. So I've got my first priority here, my second, my third, and my fourth. So 1, 2, 3, 4. It's going counterclockwise, so mirroring it does work. So I'll do that again, just to make sure that everyone's got it. We're going to do the first carbon first, get these two priorities, and then we'll jump to the last carbon, and then we'll get those two priorities. So in the first carbon, I have my methyl as my first priority, my hydrogen will be my second. I jump to the back molecule, and then I've got my methyl as the third priority in total, and my hydrogen as my fourth. So 1, 2, 3, and 4. S. I hope that helped. Let me zoom out a little bit. Okay. So let's see if we got it right. Okay. So that's it. I hope this isn't too hard for you. I know it took me a while to get used to, but I think the hardest part is probably the Newman projections. But good luck. You got this.